So in 4.4, we're going to be solving logs, and to do that, we have to know these properties. We have to know some, not just these, we'll learn more as well. Okay, well, you have to know the properties. You don't necessarily need to write down the reasons, but if you want to at least read them, so you can kind of understand where we get these properties. I'm not going to ask you to write the properties down, but in order to solve the equations, we'll have to know them. You'll have to understand how to use them. So log base b of b is 1, okay? So if your base is the same of what you're taking the log of, you get 1. Log base b of 1 is 0, so no matter what your base is, if you take the log of 1, you're going to get 0. Those properties 3 and 4, we talked about those on Friday, how they're inverses of each other. So log base b of b is like take squaring a square root, and you're left with x. Okay, same thing, b to log base b of x. Those are inverses of each other, so you're just left with x. Okay, so we're going to use those to do a little bit of solving. You're going to want a calculator. It can be a scientific calculator, it can be your phone. If you don't have anything or you want to use one of the graphing calculators, they're up here. Okay, so what we're going to do is using natural log and e, because those buttons are on your calculator. Alright, so I have the natural log of x is 1/2. So x is inside this natural log function. So the natural log is a function. It is an operation. So it's not a number where you could just divide by a natural log on both sides. That does not make sense. That makes as much sense as dividing by an empty square root. Okay? That's doing this. If you're trying to divide by just a natural log by itself, that's like dividing by an empty square root. You cannot do that. Those are operations. Okay? So what I want to do is do the inverse of natural log, so I can cancel it that way. So like a square root, the inverse would be to square. So natural log, when you're doing logs, the inverse would be to exponentiate. So natural log is log base e. So I'm going to exponentiate both sides with base e. So to exponentiate means to take what I have and put them in the exponents. Okay, then I got e to the natural log can cancel, and I'm left with x equals e to the 1/2. So that is my exact answer. Okay, then I want to round to the nearest thousand. So that's 3 decimal places. So e to the 1/2. So that's 1.649. Okay. So you should have gotten with the calculator. And if you're not getting that, then you're just probably typing something in wrong. Talk to me. I can walk you through, maybe show you what to do. If you're using your phone, you have to do the 1/2 first. You have to type in 0.5 or 1/2, and then hit the e to the x button. Okay. This time, I have an exponential function. X is in the exponent. So I need to do the inverse of an exponential. The inverse of an exponential is a log. And I have to make sure the base is the same. So log base e is natural log. So I'm going to take the natural log of both sides. My natural log of e cancels, and I'm left with x equals natural log of 0.343. So now I can type that in. It says thousand, so 3 decimal places. So negative 1.070. Okay. On this one, I want to find the exact form and then approximate. So the exact form is the x equals before you type it in your calculator. So we're going to wait to do any rounding till the very end, till we have x by itself. So I first want to look and see where my variable is. Well, my variable is in an exponent. So I know I'm going to have to use natural log. I'm going to have to do natural log of both sides. But I can't do that until I have e by itself. So I'm going to have to move the 2 and the negative 3 first. So I have to first subtract 2 from both sides. And then we can divide by negative 3. Now that I have e by itself, I can take the natural log of both sides. So this 0.4 is with x in the exponent. So I can't do anything with that until I move the e. So until I get rid of e. So go ahead and take natural log of both sides. Do not round yet. So if I type in natural log of 3, I get a decimal. It's an irrational number. So I'm going to just keep it natural log 3 for now so I can keep an exact form. So those cancel. And I have 0.4x equals natural log of 3. So having natural log of 3 is kind of like having radical 3. So I want to keep it exact So right now I keep the natural log with it. One thing now to get rid of it, to get x by itself, I can divide by 0.4. So the exact answer is natural log 3 divided by 0.4. Okay? And then to find approximate, type that in your calculator. Do natural log of 3 divided by 0.4. So wait to do the rounding until the end. Yes. It said round to 4 decimal places. So 2.7465. What you guys got? Yeah. Okay. Questions so far? Okay, let's get another one. Okay, Hannah Singer, what would I do first? Subtract 7. Good. Okay. So my x is inside that natural log function. I need to get the natural log by itself. Okay. So Jacob, what now? Okay. How would I do that? Divide by -8. Good. We don't want to round, so let's keep things as reduced fractions. Even though this would be a terminating decimal, let's go ahead and keep it as a fraction. So that would be positive 11 over 4. I can't do anything with the 3 yet because that's inside the natural log function. Okay. So Mason, what would I do now? Okay, exponentiate both sides by e. So that means take what you have and put it in the exponent with base e. Good? So what cancels here, Maya? The right side element. Okay, so e in natural log, good. So I'm keeping this, I'm not rounding yet, I'm keeping that e to the 11/4. And then on the right, I now have 3x. Okay. And then Kyle?
Divide by 3.
Yep. Divide by 3. So my exact answer is e to the 11/4 divided by 3. Let's round to 4 decimal places again for an approximate answer. it does, the only way, since e itself is irrational, the only way you get a whole number is either e to the 0, which is 1. Everything else would have to be rounded. Yep. Okay. 5.2142. Okay. Questions about that? Okay, so if we have natural log or e or log base 10, like common log, then we don't have to worry because those buttons are on any type of calculator we're using. But if we want to do log base something else, like base 6, then we need a way to do that in our calculator, a way to approximate. The newer graphing calculators have log base b, where you could put any number you want. But the older ones, like the ones I have here, your scientific calculators, all of those have only base 10 or natural log. So we're going to learn change of base. It's part of the curriculum anyway. And this is what I'm going to use. Okay, so you'll still want to know how to do change of base. So this gives me a way to find log base b, where b is anything, of m, where m is anything. Basically what this says, this is the property, so this is what's true. Log base b of m can be rewritten as log base a of m and log base a of b. So as long as you're doing the same base on top and bottom, you can get the answer to log base b of m. Now we're not going to use just anything because we want to use the buttons that are on our calculator. So we'll either do common log, okay, or natural log. Both of those buttons are on our calculator, so we'll use either one of those. So when I approach this problem here, I'll come back up. When I approach this, I want to first see if I can answer this without a calculator. See if I can rewrite it in exponential form and figure out what it is. So if I rewrite it in exponential form, that's 5 to the x equals 7. Well, is there a rational or an integer number that I could get for x? Do I know 5 to what power gives me 7? No. So this is where I have to use the log to figure this out. I can kind of think about it a little bit, though. So 5 to the first is 5. So I know it's bigger than 1, right? 5 squared is 25, so it's got to be less than 2. So it's some number between 1 and 2. Okay, so what I'll do is I'm going to use change of base. I'll use natural log. So what I do is I'll do natural log of 7, so the big number goes on top, over natural log of 5. The base goes on bottom, and that becomes what you're taking the log of. Okay, so type that in. Natural log of 7 divided by natural log of 5. I could use natural log or common log, but I chose what common log is log base 10. I chose one of those because those are the buttons I have on my calculator. Okay, so natural log of 7 divided by natural log of 5. I got, let's just go 3 decimal places. 1.209. Does that answer make sense? Then we say the number should be between 1 and 2. Probably closer to 1, since 7 is closer to 5 than 25. But let's do common log too. So now instead of natural log, use the log base 10 button on your calculator. And you should get the exact same thing. So it does not matter which one you use. I tend to use natural log, and the only reason is because I like writing LN better than LOG. That's the only reason. So it's a letter shorter. It doesn't matter though. You can use either one. Okay. So we're going to have to use that when we're doing some solving with bases other than E or other than 10. So let's look at a few examples just so we can get practice with this. So we're gonna do this top part here, and then we're gonna do this expand and simplify tomorrow. So what I want to write is common is log base 10. So y equals, I'm rewriting this part right here. So log base 10 of x over log base 10 of 3. I don't know what x is, so I can't get an actual value for that. I just have to leave it as is. So do the same thing for natural log. So that's natural log of x over natural log of 3. Okay? All right, so we'll stop there.